My name is Ani. I'm your wallet guy. I work at Brave. Brave is a privacy internet stack. You probably know about us from the popular Brave browser and probably Brave search. But we also have a EVM wallet built right into the browser. There's a wallet icon if you already have Brave. And it's just like MetaMask, it's non-custodial. It's written in C++, and we ship it to our 60 million users. But today, what I'm going to talk about is um, uh, the perils of DeFi. So back in 2021, something happened. So I read a news that the Discord for BAYC was hacked, and some bored apes were stolen. So I thought, okay, what does Discord chat room have to do with my bored apes, right? I'm not keeping my bored apes there. So apparently, what happened is um a lot of bored ape holders are unsophisticated. They probably clicked on some link that they were not supposed to, and that drained their wallet. Okay, which is pretty common. So there's something happening there. Um, can you reload the page? I don't see. Co- yes. Uh, uh, no, still, I think there's something missing. Uh, maybe just give a refresh. Sorry about that. Um, Never mind. I'll improvise. It's okay. It's all right. So what I was going to show you. So the reason why it's not there is I just saw a tweet that says there is a the FTX drama. You thought I wouldn't mention it in ETH Gathering, but apparently it has something to do with my talk. So there is a fun tape of Caroline and SBF apparently that's like being talked of, and there are these links. If you want to view the this video, you have to sign in with your wallet. It doesn't show anything, but it drains your BAYC. So 121 bored apes were stolen because people wanted to. Yeah, it happened like yesterday. It's still happening. We have to see. It's crazy. And it's not just about draining a wallet. Maybe they transfer you an SBT saying that, Vitalik.eth viewed this video. Who likes SBTs now? So it's your address is tainted forever. Um, so why is this happening? It's happening because of something called blind signing. This is something we do on a daily basis. When you interact with a smart contract, you just approve like whatever. You don't even care what it's about and say, okay, just confirm and do. I trust you completely. All right. So this is an example. This is a Uniswap transaction, but if I didn't tell you, you probably would not know. It has bunch of hex. It says nothing about what's happening. It shows you what the gas fee and the total amount trying to spend, but doesn't say what the amounts are, what the assets are involved, and so on. I don't recommend clicking on confirm. Uh, what about this? So, would you click on confirm? So often you see zero ETH. So the definition of good UX these days is if it's complicated, just hide it, right? So there's a view data button right at the bottom. If you click on that, you'll see the hex. But normally, i i pretty much your whole transaction is about this small hex, right? Uh, So that's not good UX. This can take your life savings maybe. And it's even the case for a hardware wallet. See 0 ETH, and your ledger says there is data, but it doesn't say what data it is, like what it's going to do. So a hardware wallet is not going to protect you either. So this data is in technical terms known as call data. So I've highlighted this in a red box. This is an EtherScan transaction. And the unreadable stuff that you see in the input data segment, this is pretty much defining what your transaction is going to do. It's like for an API, you interact with it through HTTP request. So for smart contracts, you interact using call data. So everything that the contract must do is defined in this, is encoded in this. Maybe it is about stealing your Bored Apes, but we don't know. It's impossible to read this. So let's try to understand, let's try to dive deep into what call data is, how it's working, and how EVM is interpreting this behind the scenes. So we take a simple function that adds two numbers. And if you want to execute this function, just create a transaction that has this kind of hex in the data segment. Normally, it wouldn't make any sense, but if I break this down into segments, it starts making sense, right? So recall that it's an add function with two uint256 numbers. So the first 4 bytes is known as a function selector. It defines what the function is going to be, like what should EVM execute. And each argument takes 32 bytes each. And now you can, so 0ff, it's probably some number. 001, that's also, that's the integer 1. You add them together, you get your result. So now it starts making sense. This is exactly how the EVM is interpreting this behind the scenes. So I just, you don't have to really understand what's going on, but I just filled in the contents of this contract using the same parsing logic I just talked about. So you load the address of A, the position, the starting position of your call data. The number B is 32 bytes after that. You copy the 32 bytes into A, 32 bytes into B, and the result is the addition of the two. So this is exactly what EVM is doing if you just pass in some call data to this function. So we just implemented a ABI decoder in Solidity. It's that simple. So what if we do this on the wallet level? When you're creating a transaction, what if we do the exact same thing and give the user some kind of information on what's going on? So let's take a more sophisticated example. This is one of the most popular methods used on Ethereum. It's a 0x function called sell token for token to Uniswap v3. Normally, if you open a transaction on EtherScan, it would look like this. It doesn't make any sense. But if you start passing it in the way that I talked about and match it with each one of those arguments, it would start to make sense. So I made this small diagram. Okay, it's not that complicated actually. So like I said, for any transaction, the first 4 bytes is going to be is defining what is the function being invoked. Following that, each 32 bytes is your argument. So recall that you have 4 arguments. So that's 4 times 34 bytes. So first argument is the something called a path. Then your sell amount, this is the amount that you're trying to spend. Then the amount that you get, it's a swap function, right? And finally the recipient, normally it's your own account address. And even if you go back to the function definition, the path is a bytes. The path is a bytes, which means it's dynamic. Unlike the other fields, it is not of a fixed size. You could encode arbitrary amount of data in it. So how do we fit that in 32 bytes? What if it's more than 32 bytes, as in this case? So what the EVM provides us is something known as a head-tail encoding, which means instead of adding all this bytes information, trying to pack it in the 32 bytes, provide a pointer within the call data, which has all the information. So uh, you see the value of encoded path, which is the bytes, is 0x80, which if you convert to a decimal, it's actually an index in your call data bytes sequence, and that is where you have all the information about your swap order. So in this case, it first encodes how long your path is. It has information on what token you're trying to swap. So in this case, it's a cow token. Then you go to wrapped ether, and then finally you get USDC. So in summary, if you're able to pass this whole transaction called data, you can infer that it was a cow to USDC swap. You can infer what is the from amount and what is the to amount. So what is the end product? Okay, these things is cool, but does it make any sense to the user? Not at all. So this is what we built. It is, in my opinion, I think you would agree that this is significantly better than just seeing 0 ETH and a bunch of hex. And this is what I think is good UX. When you don't hide information, rather you present it in a way that gives the user the confidence that, okay, I should click on this confirm button. So you can see all the information about your swap. You can see your exchange rate and so on. You can see the security critical information, like what is the origin of the transaction. It doesn't have to originate from within Brave wallet. It could be any other DApp. Like I gave the example of Matcha, and it shows it would work for the same user experience would work for bridge transactions as well, if you're trying to go from one chain to another. And I think that's something that we as an industry should push, and we as users should demand from our wallets, from our dApps, that they present information in a way that makes it safe. So I would say this is a safer way of signing, right? And this is something that we at Brave are focusing on and expect to see more of these kind of things in the coming future. So that's it. That's my little talk. And I mean, as tempting it may be, I would advise against clicking on links to watch videos or those kind of things. So that's it. That's all I have. Are there any questions?
So you just mentioned a few moments ago that this doesn't only work with, I guess, the user's Brave wallet. It can be like any other dApp. Like, what exactly do you mean by that?
Because
so if like someone is using, let's say, a MetaMask wallet, is there also some kind of functionality from Brave that you can build into I guess the app that you're building to show this?
Right. So Brave is just a non-custodial wallet. So what I meant by that is, if you are trying to do a swap on Matcha, right? So from the wallet's point of view, it doesn't matter. All it matters is what's in your transaction call data. And this is something that we are able to parse and make sense of it and present it in a way that also makes sense to the user. So because if it's happening inside Brave Wallet, it's pretty easy, right? We know everything about the transaction, so we can show whatever we want. But if it's a transaction that we don't control, the construction is not in our hand, we should still be able to parse it and display the information. So we achieve this with a generalized ABI decoder. So like tomorrow, if you want a curve, you want to know what a curve swap looks like instead of signing like blind signing piece of hex. So it is pretty easy to support that as well, and it will look pretty much the same.
Sorry, Annie, I do have a question. What do you think is like the biggest challenge for wallets looking forward? Apart from, like you mentioned, gave your talk on blinding sign, what do you think is like other big challenges that wallets need to solve in the nearby future?
So first of all, it is really not that intuitive to use wallets, right? Like most people, like lame users, would treat it as a bank account. They don't understand, why do I need an ETH balance? Why do I, where I'm spending USDC from my account? So there are some user experience challenges. Okay. Then there is also stuff like your signing experience. This is something that we have spent almost like 6-7 years building wallets, right? Like Ethereum since 2016, we have mature wallets at this point, but the signing experience is more about hiding information than presenting it in a useful way, right? And I would actually even point out that there is an even better way of solving this kind of problem, which is simulations. So what you would do is instead of trying to figure out what the transaction call data means, you would fork the mainnet, play your transaction, and try to observe how it changed the EVM state, and then present that to the user instead. So that's even a step ahead, and a lot of wallets are trying to do that these days. And that's actually one thing that we should learn from Solana, which is Solana wallet. Solana has a dedicated RPC in the default specification that simulates a transaction, and it's part of the wallet. So it's super intuitive to, even though it's complicated, like whatever the most complex transaction you can think of, you can still make sense what it's trying to do.
Yeah, I think you kind of partially answered it, but parsing the cold data doesn't give me any security actually, because I can, first of all, like if it is a contract that is not really well known, I mean, I guess that the wallet will have a hard time interpreting the cold data, but also I can just create a method called swap, you know, and then internally steal your ape.
Yes.
So the simulation is the way to go.
Exactly. Simulation is the way to go. So in this case, when you sign a transaction, you're really, it's like having a contract with the smart contract. The user has an understanding with the smart contract. Okay, if the contract says, you can make the same argument for a bank account, let's say. So when you click on transfer to some person on your banking app, you're trusting that the bank doesn't like drain your funds and send it to an offshore account, right? So in this case, you have to verify what is the origin of your transaction. It's really important. It's not the, you could say that it's a swap, but it's like you said, stealing your apes. And simulation is, it is a solution, but what I think we should do is mix the two, because what you see here is the guaranteed amount that you get. This is exactly what you sign. What happens in simulation is that it's a rough estimate. So we should be able to merge the two and provide both the information to the user. That's a great question.
Yeah, so could there be a problem that you're giving false security to people using this wallet? You make it seem so beautiful and nice, and then they forget that actually, for example, can you, like if you have like $10,000 inside the wallet, right? It is usually recommended not to use the exact wallet, but you use a smaller amount of those funds to interact with other contracts, right? You don't use the wallet which you have. You don't use the address where you have all of the funds in, right?
Why not? I mean, when we build wallets, we don't really. It could be a recommendation, but we can't really expect users to. I mean, users are swapping millions of dollars using MetaMask or non-custodial software wallets, right? Yeah, and you can also pair that with a hardware wallet. So this same, I know Ledger has a concept called plugins. So if you install a plugin for a certain DApp, it would show the same information but on a hardware screen, right?
So maybe what I'm asking, would it make sense, for example, that the wallet would say these smart contracts are more secure because they were verified by Certora or something like that, because they're verified by several people. Would it make sense in the future to implement something like that, or do you think it would?
Absolutely. And I think domain scanning is something that is coming to a lot of wallets. And so Etherscan already provides you a way to see if a contract is verified or not. So that's one thing. We have ways to figure out if an origin, so the website from where the transaction was initiated, whether it's a phishing site or not by checking what kind of page rank it has, what's the DNS, like if you look up the if you do a whois query, what kind of results does it show? Is it just created 1 hour back, or so on? So yeah, those are things that we can do. And in addition to that, so what you're suggesting is something like a whitelist. That's definitely like a blue check mark for without $8, but a blue check mark based on, yeah.
Hello. Since you have Tornado Cash logo on your Twitter and you were an ETH Brno, which was dedicated to privacy, the question is this: like, what are your key learnings, especially from that event or August event with Tornado Cash, within the challenges for wallets between privacy and transparency? What's your general approach? Maybe changed within the couple of what's happening in the market, and could wallets be really private within your opinion, or should they be private? And what's this division between transparency and privacy? Thanks.
Thanks for your question. So my learnings from ETH Brno was that people raised the topic of blind signing, right? And there were a bunch of teams. I think the second prize was the team that did simulations to solve blind signing, which is great. So this is something people are talking about. It was not the case a couple of years back. So this is a real problem. I think people started losing apes, and they thought it's now a real problem finally. And even the first prize went to a wallet that uses Star by default for everything. This is great, and it's like showing examples of things you can do so that the more mainstream wallets can adopt. So I'll tell you something. So the thing I don't like about Ethereum by default is there is no baked-in privacy at the protocol level, right? If you have been a Bitcoiner, you know that there is some level of privacy for your wallet because of the concept of UTXOs. So when I do a transaction, I pick the UTXOs I want. Maybe it's KYC'd, maybe it's not KYC'd. It doesn't reveal everything about my wallet because it's not account-based, it's bag of keys model. And this gives me some level of privacy without using things like mixers because it's not clear if it's legal or not. So like I actually don't recommend using Tornado Cash to everyday users because you may be blacklisted by an exchange, your funds may be frozen in future. So we need to think about privacy features at the base layer, something that you get for free without even using sophisticated wallets, smart contracts, or even like dedicated rollups. I think it's still an unsolved problem. Users shouldn't have to use Tornado Cash to get some level of privacy, like hiding your address to begin with. So, but we can talk more about this afterwards. Thank you.
Thank you everyone for engaging in questions. Also, Mari, thanks a lot. Now we're gonna have a talk about CK rollups. Vitalik said not so long ago it's maybe more important than blockchain in the future as a technology. So, yeah, let's see how it goes. It's gonna start in about 5 minutes, okay? So you can take a little break.
Thank you.